When running type THHN cable from a basement panel through a wall and to an outside deck underneath, the National Electrical Code, or NEC, mandates the use of conduit. This requirement is in place to provide essential protection to the cable. Specifically, the conduit safeguards the cable from potential physical damage and shields it from exposure to environmental elements such as moisture, sunlight, and temperature fluctuations. Without conduit, the cable would be vulnerable to damage from impacts, abrasion, and degradation due to weather, which could lead to electrical hazards or system failure. Regarding the need for a disconnect switch for a hot tub, the NEC provides specific guidelines based on the wiring method used. If the hot tub is directly wired into its control box, a disconnect switch located outside the hot tub is not required. The NEC mandates an external disconnect only when the hot tub is connected via a cord and plug or through other plug-in connection methods. This exception for direct wiring acknowledges that the control box itself typically includes a means of disconnecting power to the hot tub for servicing or emergencies. When installing the conduit, several additional factors must be considered to ensure the installation meets code requirements and provides adequate protection. Firstly, the type of conduit selected should be rated for outdoor use and be designated as weatherproof. This ensures that the conduit itself can withstand exposure to the elements without deteriorating or allowing moisture to penetrate. Common types of weatherproof conduit include rigid metal conduit, intermediate metal conduit, PVC conduit, and liquid-tight flexible metal or non-metallic conduit. The choice of conduit material depends on the specific environmental conditions and local code requirements. Secondly, the conduit must be sized appropriately to accommodate the number and size of the conductors being installed. The NEC provides tables that specify the maximum number of conductors allowed in various conduit sizes based on the conductor's gauge and insulation type. These tables, such as those found in Chapter 9 of the NEC, ensure that the conduit is not overcrowded, which could lead to overheating and insulation damage. Thirdly, it is crucial to securely fasten the cable inside the conduit using appropriate cable ties or straps. This prevents the cable from moving or sagging within the conduit, which could cause stress on the conductors or insulation. The cable ties or straps should be made of a material that is compatible with the conduit and cable materials to avoid corrosion or degradation. Fourthly, to prevent water from entering the conduit system, it is necessary to seal the points where the conduit enters and exits the wall. This can be accomplished using weatherproof sealant or conduit fittings that are designed to create a watertight seal. Sealing these penetrations is particularly important in areas with high humidity or rainfall to prevent moisture from corroding the conductors or creating electrical hazards. Finally, it is highly recommended that the entire installation be inspected by a qualified electrician. A licensed electrician has the knowledge and experience to ensure that the work complies with all applicable codes and regulations, including the NEC and any local amendments. An inspection can identify potential safety hazards or code violations that may have been overlooked, providing peace of mind and ensuring the long-term reliability and safety of the electrical system. In summary, when running type THHN cable from a basement panel to an outside deck, using conduit is a mandatory safety measure to protect the cable from physical damage and environmental exposure, according to the NEC. A disconnect switch is not required for a directly wired hot tub. Proper conduit selection, sizing, cable securement, and sealing are crucial for a safe and code-compliant installation. Always consult with a qualified electrician to ensure adherence to all applicable regulations and best practices. Let's delve further into the specifics of conduit installation, focusing on the types of conduit suitable for this application and their respective installation requirements. Firstly, rigid metal conduit, or RMC, is a heavy-duty option that provides excellent physical protection for conductors. It is typically made of steel or aluminum and is suitable for both indoor and outdoor applications. RMC is often used in areas where there is a high risk of physical damage or corrosion. Installation of RMC requires specialized tools and techniques, including threading and cutting the conduit to the desired length. Fittings for RMC are also threaded and must be tightened securely to ensure a watertight connection. Because RMC is conductive, it must be properly grounded to prevent electrical hazards. Secondly, intermediate metal conduit, or IMC, is a lighter weight alternative to RMC that offers similar protection. IMC is also made of steel and is galvanized to resist corrosion. It is easier to work with than RMC as it can be cut and threaded with standard tools. IMC is commonly used in commercial and industrial applications where a high level of physical protection is required. Like RMC, IMC must be properly grounded to ensure electrical safety. Thirdly, electrical metallic tubing, or EMT, is a thin-walled conduit made of steel or aluminum. EMT is lighter and easier to bend than RMC or IMC, making it a popular choice for many indoor applications. However, EMT is not as robust as RMC or IMC and is not recommended for use in areas where it is likely to be subjected to physical damage. EMT connections are typically made using compression or set screw fittings, which must be tightened securely to ensure a reliable connection. EMT can be used outdoors if it is installed with fittings that are listed for wet locations. Fourthly, rigid polyvinyl chloride conduit, or PVC, is a non-metallic conduit that is lightweight, corrosion-resistant, and easy to install. PVC conduit is commonly used in underground and direct burial applications, as well as in areas where it is exposed to corrosive chemicals. PVC conduit is joined using solvent cement, which creates a strong, watertight bond. Because PVC is non-conductive, it does not need to be grounded. However, it is important to use grounding conductors inside the conduit to provide a path for fault current. Fifthly, liquid-tight flexible metal conduit, or LFMC, is a flexible metal conduit that is covered with a waterproof plastic coating. LFMC is used in applications where flexibility is required, such as connecting to motors or other equipment that vibrates. LFMC is also used in wet locations as the plastic coating provides protection against moisture. LFMC fittings are typically compression or threaded type and must be tightened securely to maintain a watertight seal. LFMC must be properly grounded using a separate grounding conductor. Sixthly, liquid-tight flexible non-metallic conduit, or LFNC, is a flexible non-metallic conduit that is similar to LFMC but is made of plastic instead of metal. LFNC is lightweight, corrosion-resistant, and easy to install. It is commonly used in applications where flexibility is required and where there is no need for grounding. LFNC fittings are typically compression or threaded type and must be tightened securely to maintain a watertight seal. When selecting conduit for the THHN cable installation to the outside deck, consider the following factors: the environmental conditions at the installation site, including temperature, humidity, and exposure to sunlight. The potential for physical damage to the conduit and cable. The local code requirements, which may specify the type of conduit that is allowed in certain applications. The cost of the conduit and installation. In addition to selecting the appropriate type of conduit, it is also important to follow these best practices for conduit installation. Firstly, ensure that the conduit is properly supported using conduit hangers or straps. The NEC specifies the maximum spacing between conduit supports, which depends on the type and size of the conduit. Secondly, ream the ends of the conduit after cutting to remove any sharp edges that could damage the cable insulation. Thirdly, use a conduit bender to create smooth, gradual bends in the conduit. Avoid sharp bends, as they can make it difficult to pull the cable through the conduit. Fourthly, lubricate the cable with a wire pulling lubricant before pulling it through the conduit. This will reduce friction and make it easier to pull the cable. Fifthly, seal the ends of the conduit with duct seal or sealant to prevent moisture from entering the conduit. Sixthly, properly ground the conduit system according to the requirements of the NEC. Next, let's address the specific requirements for grounding and bonding the conduit system. Grounding and bonding are essential for electrical safety, as they provide a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC specifies detailed requirements for grounding and bonding electrical systems, which must be followed to ensure safety. Firstly, for metal conduit systems such as RMC, IMC, and IM, the conduit itself can serve as the grounding conductor, provided that it is properly connected to ground. This is typically accomplished by using grounding bushings and bonding jumpers at each end of the conduit run. The grounding bushings are installed on the conduit and connected to a grounding electrode conductor, which is typically a copper wire that is connected to a grounding electrode, such as a ground rod or water pipe. The bonding jumpers are used to connect the conduit to other metal enclosures, such as junction boxes or equipment cabinets, to ensure that all metal parts are at the same electrical potential. Secondly, for non-metallic conduit systems, such as PVC and LFNC, a separate grounding conductor must be installed inside the conduit to provide a path for fault current. The grounding conductor is typically a copper wire that is run along with the circuit conductors and is connected to the grounding electrode at the service entrance. The size of the grounding conductor is determined by the size of the circuit conductors according to the NEC. Thirdly, for flexible metal conduit systems such as LFMC, a separate grounding conductor is also required, unless the conduit is specifically listed for grounding. The grounding conductor must be sized according to the NEC and must be installed inside the conduit along with the circuit conductors. Fourthly, it is important to ensure that all grounding connections are tight and secure. Loose or corroded connections can increase the resistance of the grounding path, which can reduce its effectiveness in clearing a fault. Grounding connections should be inspected periodically and tightened as needed. Fifthly, the grounding electrode system must be properly installed and maintained. The grounding electrode system typically consists of one or more grounding electrodes, such as ground rods, water pipes, or concrete encased electrodes. The grounding electrodes must be installed in accordance with the NEC and must be properly connected to the grounding electrode conductor. The grounding electrode system should be inspected periodically to ensure that it is in good condition and is providing a low impedance path to ground. Returning back to the hot tub disconnect, the NEC provides specific requirements for disconnect switches for hot tubs and spas. These requirements are intended to provide a safe and convenient means of disconnecting power to the hot tub for servicing or emergencies. Firstly, as mentioned earlier, a disconnect switch is not required for a hot tub that is directly wired into its control box. However, if the hot tub is cord connected or has a plug-in connection, a disconnect switch must be installed within sight of the hot tub and readily accessible to the occupants. The disconnect switch must be rated for the voltage and current of the hot tub circuit and must be capable of interrupting the circuit under full load. Secondly, the disconnect switch must be located at least 5 feet away from the inside wall of the hot tub, unless it is separated from the hot tub by a permanent barrier. This requirement is intended to prevent occupants from reaching the disconnect switch while they are in the hot tub, which could create an electrical hazard. Thirdly, the disconnect switch must be clearly labeled to indicate its purpose. The label should read hot tub disconnect or similar wording. Fourthly, the disconnect switch must be lockable in the open position. This allows the power to be safely disconnected during servicing or maintenance. Fifthly, the NEC also requires a ground fault circuit interrupter, or GFCI, protection for all hot tub circuits. A GFCI is a device that detects ground faults, which are electrical leaks to ground, and quickly interrupts the circuit to prevent electrical shock. The GFCI protection can be provided by a GFCI circuit breaker or a GFCI receptacle. In addition to the NEC requirements, local codes may have additional requirements for hot tub installations. It is important to check with the local building department to determine the specific requirements for your area. It's very crucial to emphasize the importance of electrical safety in all electrical work. Electrical work can be dangerous if it is not performed properly. It is important to follow all applicable codes and regulations and to take the necessary safety precautions to prevent electrical shock or fire. Firstly, always turn off the power to the circuit before working on it. Use a voltage tester to verify that the power is off. Secondly, wear appropriate personal protective equipment such as safety glasses and rubber gloves. Thirdly, use insulated tools to prevent electrical shock. Fourthly, never work on electrical equipment in wet or damp conditions. Fifthly, if you are not comfortable performing electrical work, hire a qualified electrician. These measures are for safety.